Hello students, welcome to our YouTube channel Experience Tutor. Today we'll discuss class 10th science periodic classification of elements. This is our mission to provide free classes on YouTube for all students of class 10th to class 12th, special classes for students preparing for IIT, JEE, NEET, NDA and other competitive examinations. Before we begin today's class, we have a small request for you to subscribe, like and share this channel among your friends and relatives. Please click on the subscribe button to support us and also click on the bell icon to get automatic notification whenever a new video is uploaded. Let us begin the lesson. Periodic classification of elements, chapter 5, class 10th. Now, in the previous chapters, we have studied about the matter around us, and in that we have studied that matter around us is present in the form of elements, compounds, and mixture. Elements are the purest substance containing atom of one type. For example, sodium, magnesium, gold, etc. There are 118 elements known to us. All these have different properties. Then the first question which comes to our mind, that why there is need of periodic classification. As we told that there are 118 elements and all have different properties. Therefore, it is very difficult to analyze the properties of all the elements. To find out the similarities in properties, dissimilarities in properties. Therefore, to study all the elements in a structured, systematic manner, we need to do the periodic classification, which will make the study of element easy, and 118 elements will be reduced into few groups of elements. So, in this step of classification of elements, Daubernier's triad was the first initiative taken by Dauvergne. According to him, when elements were arranged in the order of increasing atomic mass, groups of three elements known as triad having similar chemical properties are obtained. So, the atomic mass of the middle element of the triad was roughly the average of the atomic masses of the other two. So this was Daubernier's concept. To understand his concept, let us take an example. Element, we have made two columns, one for elements, other for atomic mass of that elements. Calcium, first element is calcium, atomic mass is 40.1. Second element is strontium, whose Next element is Sr, that is strontium, whose atomic mass is 87.6, and third element in this triad was barium, Ba, whose atomic mass is 137.3. So if we find out the average of calcium and barium, then we found that it is approximately, it comes 88.7, which is approximately equal to the strontium atomic mass. So this was the concept. Now his theory was rejected because it was not true for all the elements. Now what was the his what was the limitations of his theory? So limitations of his theory were only three triads were recognized from the elements known at the time. They were first triad, lithium, sodium and potassium; second triad, calcium, strontium and barium; and third triad, chlorine, bromine and iodine. So this his theory was rejected after some time when new elements were discovered which doesn't follow his rule. After that, Newlands gave a new concept for classification of elements, and his law was known as Newlands Law of Octaves. According to that law, Newland arranged the then known elements in the order of increasing atomic mass and found that the property of the eighth element is similar to that of the first element. Fine. He compared this to the octave found in the music and called it the law of octaves. Now, to understand his theory, let us see an example. So here in the example, we can see if we start from hydrogen and uh, the eighth element is fluorine. Again, if we start from fluorine, the eighth element is chlorine, and in this way, hydrogen, fluorine, and chlorine have similar properties. So hydrogen and fluorine is similar, have similar properties. Again, fluorine and chlorine have similar property. Therefore, we concluded that hydrogen, fluorine, and chlorine have similar properties according to the Newlands law of octave. His theory was also rejected after some time. So what were the limitations? The first limitation was it was applicable up to calcium. It doesn't work after calcium in the periodic table. So second reason for rejection was property of new discovered elements did not fit into the law of octave. Fine. So these were the basic two reasons why Newlands law of octave was rejected. After that, Mendeleev came with new concept for the classification of elements. According to and he gave it was known as Mendeleev's periodic table. So, what was the main characteristics of Mendeleev periodic table? The property of elements are the periodic function of their atomic masses. First feature. Second feature, Mendeleev's periodic table contains 8 vertical columns and 7 horizontal rows called periods. The columns were known as group and the rows were known as periods. Achievements of Mendeleev periodic table. So, achievements of Mendeleev periodic table. First achievement was the elements with similar properties could be grouped together. Second, some gaps were left for the undiscovered elements. And the third one, noble gases could be placed without disturbing the existing order. After some time, Mendeleev periodic table was also rejected because it was not true for all the elements. Its limitations were: first, no fixed position for hydrogen. Second, no place for isotopes. Third, no regular trend in atomic masses. Means, in some places, higher atomic masses came first, then the lower atomic masses. After the rejection of Mendeleev periodic table, new concept for classification of element came into existence that was known as modern periodic table. Now, modern periodic law. So, modern periodic table is based on modern periodic law. What is modern periodic law? Properties of elements are the periodic function of their atomic number. Initially, everyone taken as a atomic mass. In modern periodic law, we have changed atomic mass to atomic number. So, properties of elements are the periodic function of their atomic number. Now, what are the characteristics of modern periodic table? First, atomic number, which was denoted as Z, is equal to the number of protons present in the nucleus. Second, there were 18 vertical columns known as groups and 7 horizontal rows known as periods in the modern periodic table. Third one, elements with same number of valence electrons are placed in the same group. For example, lithium valence electron is 1, sodium's valence electron is 1, electronic configuration 281, so valence electron is 1. Potassium electronic configuration is 2881, so valence electron is 1. So in all these three elements, the valence electron is 1. Therefore, they are kept in the same group. Fourth, number of cells increases as we go down the group. Fifth, elements with same number of Elements with the same number of, of cells are placed in the same period. Elements with the same number of occupied cells are placed in the same period. So let us take an example. Lithium. So for example, lithium electronic configuration is 2 1. Then barium electronic configuration is 2 2. Boron electronic configuration is 2 3. Carbon electronic configuration is 2 4, and nitrogen electronic configuration is 2 5. So in all these 5 elements have same number of cell, that is 2. Therefore they are kept in the same period. Sixth, maximum number of electrons that can be filled in a cell is given by 2n square, where n is the number of cell. So this also we can explain with an example. Say for example, for k cell n is equal to 1. So putting this into the formula 2n square, that is 2 1 square, that is 2. First period has 2 elements. So first period has 2 elements. Now L cell n is equal to 2, which implies that 2n square, that is 2, 2 square, that is 8. Second period has 8 elements. In this way it goes on. Next property, property number 7, position of an element in the periodic table tells us its chemical reactivity. So which element is more reactive, which element is not, we can see from the periodic table, and we can say, so if we move from left to right in the periodic table, the reactivity of element increases. This example. So, and the last property, the eighth one, is valence electron determines the condition and the kind and number of bond formed by the element. So there may be different types of bond like covalent, electrovalent, ionic bonds. So or uh, so the valence electron decides that what type of bonds will be formed, and these are the features of modern periodic table. Trends of modern periodic table. First, valency. Valency. What is valency? Number of valence electron present in the outermost cell of its atom. So on moving from left to right on a periodic table, the valency of the element increases from 1 to 4, then decreases to 0. Valency remains same in a group, top to bottom of a group. Second is atomic size. size. So, atomic size is referred to the distance distance of the is referred to the radius of the atom. So how we measure the radius of the atom? From the nucleus to the outermost cell of the atom. So atomic size of an atom decreases as we move from left to right of the periodic table, because as we move from left to right, the nucleus, the positive charge of the nucleus increases, and the force of attraction on the electrons in the different cell also increases, and the size of the uh, and therefore the electrons are come more closer to the nucleus. Therefore the size decreases as we move from left to right of a period. But oppositely, if we move from top to bottom of a group, the atomic size increases, because in every step the new cell is added, and therefore the distance from the nucleus to the outermost cell increases as we move from top to bottom in a group. Now metallic character. Next one is metallic character. Metallic character means the tendency of an atom to lose electron. Metal loses electron. Remember, metals occupies the left hand side of the periodic table. On moving left to right of the periodic table, the metallic character of an element decreases because the effective nuclear charge increases. It means the tendency of losing electron decreases, because as the charge increases, nucleus attracts the electrons in the orbits towards itself. So it is little bit difficult to lose electron in that case. Metals are electropositive, and they tend to lose electron while forming bonds. Metallic character increases as we go top to bottom of a group, as the effective nuclear charge is decreases, because the size of the atom is increases. So distance between the nucleus and the valence electron is less as we move down towards the group. Therefore losing characteristic of electron increases, and metallic character increases. Now non-metallic character. Non-metallic character. So what is non-metallic character? Non-metallic character means tendency of gaining electron. Non-metals are electronegative, as they tend to form bond by gaining electrons. Non-metallic metals occupies the right side of the periodic table. Non-metallic character increases across the period as we move from left to right towards the period, because due to the increase in effective nuclear charge, and that means tendency of gaining electron increases. Non-metallic character decreases as we move down towards the group due to the decrease in effective nuclear charge experienced by the valence electron, because the size of the atom increases and the distance between the nucleus and the valence electron increases. In the middle of the periodic table, we have semi-metals or metalloids because they exhibit both the properties metals and non-metal. Oxide of the metals are basic in nature, while oxides of the non-metal are acidic in nature. And this is the end of this chapter. Before we close, we have a small request. Please subscribe, like, and share our channel. Please click on the subscribe button to support us, and also click on the bell icon to get automatic notification whenever a new video is uploaded by us. Thank you very much to support Experienced Tutor YouTube channel.